Welcome to Vayani Tutors. Today in the session, we'll cover unit number 5, writing classes, that carries 5 to 7.5% of the total weightage in the exam. We have learnt about classes and objects that are built into Java or written by other programmers in the earlier sessions. In this unit, we'll be learning to write our own classes and objects. Let us see how to create a class now. Class in programming defines a new abstract data type, and objects create new variables or instances of that class data type. Let us consider class as a blueprint or design of objects, or the class house below is a blueprint of a house and the objects which are individual houses built from that blueprint. We cannot define objects without a blueprint. In order to write our own classes, we typically start a class declaration with a public class followed by the name of the class. The body of the class is defined inside the curly braces. Then we create objects of that new type by using class name, object name is equal to new class name. For example, if we create a public class house, here we define the class or a blueprint, then house, my house is equal to new house. House, neighbor's house is equal to new house. Each objects have attributes and behaviors, also known as properties and functions. These correspond to instance variables and methods in the class definition. Instance variable hold the data for the object, whereas the methods code the behaviors or the actions the object can do. A class also has constructors, which initializes the instant variable and the object is created. Example, the new house above. And a class can also have a main method which can be used to test the class. Instant variables hold the data for an object. In other terms, they record what an object needs to know to do the work in the program. Instant variables are also known as attributes, fields, or properties. Note that instant variables are declared right after the class declaration. They usually start with private, then the type of the variable, and then a name for the variable. Private means only the code in this class has access to it. The object-oriented programming stresses the data encapsulation, where the data, that is instant variables, and the code acting on the data, which are methods, are wrapped together into a single unit and the implementation details are hidden. The data is protected from harm by being kept private. Anything outside the class can only interact with the public methods and cannot interact directly with the private instances variables. When designing a class, programmers make decisions about what data to make accessible and or modifiable from an external class. In other words, this is how a program is written. Private string first, then private string last. Now let us see what are methods. Methods define what an object can do or perform or the behavior of the object. Most of the methods are public, which means they can be accessed from outside the class. Some methods can be marked as private too if they are helper methods that are just used internally by other methods inside the same class. To explain further with an example, here the example of print, method that prints out the data stored for a person object. Notice that it starts with the public and then returns the type. The void return type is used to indicate that the method does not return anything. Then it has the method name followed by the parenthesis for possible parameters. The body of the method is in curly brackets. The method can access and use the instant variables in the class name, email and phone number. The instant variables are shared by the methods of the class. Now, to call a method to do its task, we create an object of the class and then use a dot operator to call its public methods. For example, p1.print means call p1's print method. We have been told in the earlier units that Java is an object-oriented design or programming, which actually means that programmers first decide which classes are needed to solve a problem and then figure out the data and methods in each class. Similarly, now let us see What are writing constructors? In Unit 2, we learned how to create objects using constructors. Objects are created in programs by declaring a variable of the class and using the keyword new followed by a call to a constructor. Constructors are nothing but initial values for the object's instance variables. To understand the concept further, we use public class name, instant variable declaration, constructors same name as the class. This you have to remember that whenever you call a constructor, this must have the same name as the class. Constructors have no return type. Classes usually have more than one constructor. There are usually at least two constructors. A constructor that takes no parameters and a constructor that takes parameters necessary for initializing all the instant variables. You would have seen me putting these two forward lines in the codes. These are called comments. Adding comments to your code helps to make it more readable and maintainable. Usually many programmers will own your code and maintain it for years. Commenting is an essential one. In the commercial world, a team effort where many programmers will be using the same code and maintain that for years. Commenting is essential in this kind of environment and a good practice to follow. Comments will also help you to remember what you were doing when you look back to your code a month or year or a decade from now. Here are the three types of commenting. For the single comment we use two forward slashes. For multi-line comments we can use a forward slash followed by a star key, and we have to end it with a star followed by a forward. Now what if we want to comment the whole document? This is how we do it. Forward slash, two stars, then when you close it with a star followed by a forward slash. We have some precondition and post conditions. As we write the methods in a class, it is a good practice to keep in mind the preconditions and post conditions for the method and write them in the comments. A precondition is a condition that must be true for your method code to work. Example, the assumption that the parameters have values and are not null. The methods could check for these precautions, but they do not have to. The precondition is what the method accepts in order to do their task properly. And post conditions is a condition that is true after running the method. It is what the method promises to do. Post conditions describe the outcome of running the method. Example, what is being returned or the changes to the instance variables. These assumptions are very useful to other programmers who want to use our class and get the results correct. To understand the concept in a more clearer form, we see the example of preconditions and post conditions and the parameters in the turtle code that we have used in the past for our drawing turtles. And all these are commented. Software validity testing and use case diagrams, though are not covered under the APCSA exam, still they are used by professional programmers. The precondition and post condition that we learned help to test our code and determine the validity. Software validity tests whether the software does what it is supposed to do before it is released. This is sometimes very important as it checks its validity before it is put in use. The preconditions and post conditions can also help us design better software systems. Software designers often first draw a high level use case diagram of a system that shows the different ways that a user might interact with a system before they build it. There are many models for software development. The waterfall model developed in 1970s is a step-by-step model where each phase is finished before the next phase begins. This model has recently been criticized because it's not very adaptable. The more recent agile development model involves interactive incremental development where teams work in short 2 to 3 week sprints to completely develop, test and release a component of the project to the customer for feedback. Moving on to accessor methods, programmers provide public methods that allow safe access to the instance variables values in a class. Accessor methods also are known as get methods or getters, which allow a way to get the value of each instance variable from outside the class. Similarly, mutator methods are something programmers also provide a public set method to change the value of a private instance variable in a class. This is called a mutator method or setters or set or modifier methods. They are void methods, meaning that they do not return a value, but they take a parameter, the new value for the instance variable. The last session is this keyword. The keyword this can be used in a class to refer the current calling object. Example, class person, when we create an object p1 and call the constructor, or pivot.set email, the word this refers to p1. With this we come to the end of the session, unit 5. Now let's meet with the unit 6 in the coming video. Thank you.